In this question, we're given the graph of a quadratic function 1 over 2x squared plus 2x minus 1. Question A. Find f prime of x, which is the derivative of the function f of x. And we denote that as f prime of x. Cool. So since we're dealing with a polynomial here, let's use the power rule to help us find the derivative of each term in the polynomial. So start with the first term, 1 over 2x squared. So power rule tells us that we're going to bring the exponent 2 to the front times 1 over 2, then we get 1. X. Now, exponent 2 subtracts 1, we get 1. Right? So that's it. That's the derivative for the first term. Now, let's look at the second term. Positive 2x. Well, here we can actually write this as 2x to the power of 1. Okay, so power rule, we're going to bring the exponent 1 to the front times 2, we get 2. Now, x. Now, exponent minus 1, so 1 minus 1, we get 0. Okay? Next, the last term, negative 1. The derivative of any constant is 0. Just 0. Okay, so let's do some cleanup. So f prime of x is equal to 1 times x to the power of 1 is just x, right? Plus, now, guys, x to the power of 0, anything to the power of 0 is equal to 1. So here we have 2 times 1, we just get 2. And at the end we have plus 0. Well, we're adding nothing, so we don't have to write it out. So that's it. So that's the derivative. F prime of x is equal to x plus 2. So after we found f prime of x, which in this case is equal to x plus 2, now question also asks us to interpret f prime of x. What is the meaning of f prime of x? So I'm going to use the graph here to help me explain the meaning of f prime of x. If I pick any point on this graph, say I pick this point with a certain x value, then I draw a tangent line to the graph at this point. So the tangent line should look something like this. Now, the slope of this tangent line is equal to f prime of x. So let me actually write it down. The slope of this straight line, of this tangent line, is equal to f prime of x. So that's the meaning of f prime of x. In case you still find this to be a bit too abstract to understand, I'm going to pick another point on the graph, but this time with an actual number value for x. So let's say we pick this point with an x value of negative 6. Now, let's draw a tangent line to the graph at this point. So the slope of this tangent line is then equal to f prime of, see, this f prime notation represents slope. Okay? So the slope of this tangent line is equal to f prime of, now let me ask you, what's the x coordinate for this point? The x value is negative 6. So we put negative 6 inside the bracket. That's it. Okay? Now, to evaluate this expression, f prime of negative 6, we simply plug in negative 6 for x in the derivative equation. So x right here, plug in negative 6. Okay? And we still have to add 2. So the answer is negative 6 plus 2, we have negative 4. And guess what? Negative 4 is the slope of this tangent line. Now, we should expect the slope to be negative. Why? Because it's a straight line shooting downwards. Right? It's like you're driving downhill. you describe the slope of that hill to be negative, right? Now, if you're driving uphill, you describe the slope of that hill to be positive. So in this case, we have a straight line shooting downwards, so we should expect the slope to be negative. Now that you guys have a good idea of the meaning of f prime of x, let's write down the official interpretation for f prime of x. So for a function, for any function, y is equal to f of x. Now, if we pick a point on the function with a certain x value, with certain x value. Now, of course, the y value, the y coordinate for the point would just be what? F of x, right? Now, f prime of x can be interpreted geometrically as the slope. Remember? The notation f prime represents slope, right? But it's the slope of who, though? The slope of the tangent line, right? The slope of the tangent line to the graph of the function f of x. At which point? At the point x and f of x. That's it, the official interpretation for f prime of x.